This is higher level day 5 daily question, and I've got a complex number question here, and you can pause and have a read of it and do the question. It's straightforward, but it involves the way I've done it, it certainly involves a lot of algebra. So I'll go through the solution now. So here we are with our solution, and the first thing is basically to, well, it looks very complicated, but times this first part here by the two denominators there. And to do the same with the second part, so I'm timesing by 3 plus 4i and 3 minus 4i. And then exactly the same at the end here on the equal side, on the right-hand side, if you like. So I'm going to times the 5 by the two other denominators here. And in that way, we can now actually just get rid of these denominators. So that's your first part. Now I'm just going to tidy this up. So I'm going to multiply the 5i by this, by 4i. And of course, when we get these two, we've got the I squared, making it just minus 1, so we get plus 20. So just take a minute if you need to pause it and just look through how I've multiplied all of these out. Okay, this one is 9 plus 16, giving me the 25, z minus 1. And here we've got 15i minus 20. In fact, I've made a little mistake there. I can see I've made a little mistake there. It should be minus 20. It's actually just a little typo because I've done it correct in the next one. Okay, so having done that, I notice there's a factor of 5 all the way through. So I took out 5 from each one of these. And again, you might want to just double check my algebra, but the factor of 5 has been taken out. So that means I can now cancel off 5 from each part. Okay, so it's really just an algebra heavy part here. So now just go through and rewrite it. But this time I've used z as a plus bi for the first time. So I've got 3 plus 4, and then I'm going to times it by the z number, plus, and here we've got 5a and 5bi, and then take away this 5 at the end, and it's equal to 15 minus 20. So we're pretty much getting there. If you need to pause at any moment, please do and have a look, check my algebra out. Just one small typo there. So now, if we go to the next page, we've got what we had previously. I'm now going to multiply out the brackets. So 3ia plus, now when I do these, it becomes negative 3b, 4a, 4bi. I'm actually just doing this to check my own algebra. 5a, 5bi, and this minus 5 I've added to both sides. So I've now got minus 15. Now I'm going to put all the non-I numbers, the non-imaginary numbers together. So I've got 4a, 5a, 9a. I've got minus 3b, and that's the only one. And then I've got all the I numbers. So I've got 3a, 4 and 5, 9b, and I've got these numbers over here. Now we're able to say that each one has a factor of 3 in it. So I can take 3 out, so a further factor. So we can cancel all these 3's. And we're left with, eventually, a simultaneous equation, which is 3a minus b is the real part, and that's got to equal minus 5, the real part. And a plus b is the imaginary part, so it equals the imaginary part here, which is 5. Now it's a simultaneous equation. So I just copied down the first one, I multiplied the second one by 3. This one take away this is no a's, this one take away this one is 10b, and this 15 take away negative 5b ends up at 20b, so b is 2. Putting b back into one of these equations, I think I put it into this one. So I have 3a minus 2b, add 2 to both sides, give me minus 3. So 3a equals minus 3 and a equals minus 1. And so I can finish off, eventually after all that algebra, with z equals minus 1 plus 2i. Phew.